Hey everybody, thank you for trickling in. We're gonna go ahead and get started in a bit. Once Alpin is set up and ready, we'll go ahead and kick off. Should be no longer than a minute or so. And guys, please mute your mics. If you have your mic on, please mute yourself. Hey, Alpin, are you there?
Yeah,
Okay,
just got back.
perfect. Yeah, are you ready to go ahead and kick off? I can go ahead and intro you, and then we'll start things off.
Yeah, let's do it.
Perfect. So, hey everybody, thank you for coming and attending. So today's presentation is going to be on Cosmos SDK security with Alpin. Alpin is a protocol engineer and product lead over at Osmosis. He's had a hand in pretty much auditing almost every product that Osmosis has launched. He's been a big part of almost every major Cosmos-related war room over the past few years. Today he's going to be breaking down the security surface of the Cosmos SDK. Um, Strongly focusing on unintuitive and potentially deceptively dangerous implementation patterns that lend themselves easy to be higher critical issues. And yeah, again, fantastic seminar. If you're interested in Cosmos SDK security, threat modeling, attack surfaces, this is the place to be. So thank you for attending. And Alpin, I'll hand it off to you.
Awesome, thanks. And thanks for joining everyone. Yeah, so about a month ago, for the Osmosis team, we basically got around together and spent some time distilling all of the security related incidents and learnings into this, I guess, blog post type of thing. And what I want to do with this session is to be a bit more tactical and go from, general classes of bugs, etc., into, like code snippets. If you open a Cosmos code base, because there's so much going on, especially if you're coming from, Ethereum land where you're used to auditing like specific contracts as opposed to, code bases for entire blockchains. Where do you start? What are the sort of high value places to, begin an audit? All of these are things that I want to cover. Of course, I'll, first go over just a very brief breakdown of what Cosmos is, just so I'm not assuming any knowledge on the ecosystem. And then the majority will be on these sort of classes of bugs that are more or less unique to building app chain stacks, or really just like building blockchains in general, but there are a lot of foot guns. Some of these, if you were to like just pull out random Cosmos code bases in the wild, you'd probably find some of these issues sort of scattered around. So this is very much like on the frontier of security for the space. One of the reasons why I really wanted to do this was to hopefully nerd snipe more people who are talented security researchers to start looking at our code bases in the Cosmos ecosystem. So one just a quick note on what I won't be covering, and I think this might disappoint some people, but COSM, and IBC related issues I won't be touching on because I think these deserve their own sessions and are very different qualitatively. And the majority of the tens of billions of dollars of sort of asset flow that's been coming into the ecosystem has been basically through the Cosmos SDK style code bases, and I think that's where the majority of the value currently is. But maybe we can do a future session on these. Um, so let's start with just at a very high level, not related to security or anything technical. Like, what is Cosmos? Basically, it's just an ecosystem of application-specific chains. There are these like very nice visuals on this block explorer called MintScan, where you can sort of like click and drag around and see what's going on. So Osmosis is sort of the largest in terms of bridge volume, mostly because all the capital flows through Osmosis to everywhere else. There are a few other sort of familiar faces, like you can see Celestia, DYDX, etc. Have all launched their own Cosmos chains. And the ecosystem has grown a lot in, I guess, over the last year or so. And it has become, I mean, like if you look at this, the graph here, Osmosis, which is, basically the entry point to the ecosystem, has about as much like bridging activity as Solana in terms of non EVM ecosystems. So it seems like we're settling squarely into Ethereum is dominating Ethereum EVM ecosystems, and then Solana and the Cosmos ecosystem are sort of the two runner-ups. This is driven in large part by the many applications that are launching, some of which people don't even realize are building on the Cosmos stack. There just isn't another, piece of infrastructure that's so easy to use for developing application-specific chains. So there's been a lot of activity there. So who am I? I was an early contributor to Osmosis back when the team was quite small, about 2 years ago. I've been very active in the ecosystem for Cosmos, basically working on various parts of the stack, including the core Cosmos SDK. I also am like what I guess one of the few like very security minded folks in the ecosystem. Been leading a lot of our internal audits for Osmosis, and when I have time, although recently it's been busy, I try to also spend time sort of auditing other code bases as well. And yeah, again, like I said at the beginning, I think one of the issues that we have as an ecosystem is that we're bottlenecked on people who are smart and interested in security, who are intimately familiar with our stack. And this bubbles up in odd ways where you have like core team members on sort of top protocols being able to like audit code bases better than like sort of new auditors into the ecosystem, and hopefully we can slowly resolve that issue. Oh, also proud spirited anti-net investor. Okay, so that's the high level overview. Now to something a little bit. All right, normally I don't like doing these sort of like messy graphs, etc., or diagrams, but bear with me. I also want this to be useful for people to be able to like watch the recording later and sort of sift through. So I'll be basically giving some small diagrams here. So what is Cosmos? Slightly more technical. I guess a bit lower down the stack. Basically, it's a complete, a robust stack for building customized blockchains. There are many examples of blockchains that aren't even part of the ecosystem that have their starting point be the Cosmos SDK. The primary goal and export of this stack is basically splitting it up into modular standardized components where you can sort of move pieces around and make it super easy to bootstrap a blockchain while just having to implement the diff for your app, basically. So you shouldn't need to like re-implement a consensus engine, right? We already have Tendermint for that. You shouldn't have to re-implement staking logic. We already have sort of modules built out for that as well that are extremely secure and battle tested. So and the part that we're going to focus on is the Cosmos SDK, which is basically where all of the core application logic lives. And as of quite recently, actually, a new version of the Cosmos SDK went live that also lets the application layer sort of poke into the consensus layer. So some of the issues that this is extremely powerful. It lets you do things like have in protocol oracles, which is like solves many issues for per protocols, for instance. I'll get into some examples later, but it also introduces a mind-boggling number of foot guns for people who, it's a little bit like, it unconstrains the stack to a point where it's a little scary for developers who aren't that experienced with it. And yeah, this means that we need people who are experienced security researchers. This is a diagram that I think is difficult to grok. I wish I had a prettier version of it, but I think it's like a helpful abstraction for people who are sort of onboarding to the stack at first. Basically, there are three chains, and the only way that they interact with each other is through IBC. And basically, all of the logic gets sort of parsed into the consensus engine in the top left is a Comet BFD, which is Tendermint. And yeah, I'm mostly leaving this here for like later reference, something that we sort of internally had cooked up for ourselves to see sort of where Cosmos lives, where the SDK lives, and sort of how what the relationship is with other chains. Okay, so now I think like these diagrams, etc., are maybe useful conceptually, but I promised to be a little bit more tactical. So I'm going to answer the question that I would probably have if I was on the other side of this, which is, all right, given a Cosmos code base, where do I start auditing? And not because like one can sort of immediately be ready to like review a code base, because I think there's, like I said earlier, there's a lot to grok, and actually just the starting point is quite difficult to reach. So if you want to follow along, there's using DUIDXv4 as an example. Basically, if I were to audit DUIDXv4 from scratch, like where would I look? Well, we can, yeah, so we'll go from there. Basically, there's a lot of sort of boilerplate folders here that DUIDX also is a pretty complex code base. The part that we really care about is the protocol folder, which is in most other Cosmos code bases would be the root repo. Like if you open Osmosis, we wouldn't have this like higher level directory. It would just be basically what's in the protocol repo. The way that you can identify this is it has, honestly, like once you review one Cosmos code base, all of them start to become quite similar. And this is one of the great things about the stack is that it's very, very well structured. So you have all of these, basically, like if you see the app folder, then now you know that you're getting close to the core. And the component that really matters is okay, the real entry point is the application, but the part that you care about if you're reviewing a code base that's not sort of boilerplate is basically the modules directory, which is usually under the name X. And even more specifically, you want to be finding sort of all of the message entry points. And that this is basically if a user can interact with the protocol, this is how they do it. Most Cosmos code bases have this under a single file per module. So under message server, DUIDX v4 has sort of it split up for some abstraction purposes, I guess. And let's say you wanted to review their order placement logic, you would just find this sort of place order message, and this would be your top level. And then from here downwards, you can just assume that like anyone, like any user can basically submit a place order message, and you can start an audit there. Now, actually getting to a point where you have like a node or test center, et cetera, like spun up where you can do this, this is actually a bit of a challenge. I mean, like we have tooling that we're developing to make it a lot easier at Osmosis. But the TLDR is if you find a bug from this point onwards, it's probably a bug that would be good on mainnet. So if you can create a unit test that can have a message, like a message server submission here that breaks things, then you're in the money. All right, so that's the overview and sort of where to start tactically. I'm going to go into very specific like code snippet level class of security issues after this. Before I go into that, does anyone have any questions on the earlier points? Because I won't be going back sort of above water on these topics. All right, I'm not hearing anything. Okay, cool. So let's move on
Alpin, sorry,
to
real
these
quick.
specific. Oh, good.
Yeah. So, folks will ask questions in the chat instead of speaking to avoid interrupting you. So, if you look at the
Okay.
chat in the top right, you'll see that bubble. You can click that in Discord, and you should be able to see folks that are asking questions or comments.
Sorry, which channel are we in?
In the
Oh,
same
audio.
in the voice channel that you're in for the presentation, there is a voice bubble at the top right.
I see it.
Yeah.
Okay, cool. So let's see. How can you check access control in Cosmos code bases? So basically, the way it works is you have people who submit messages. That every message has a sender that's automatically bundled into the message, and the access control happens sort of basically where this code snippet was. The sort of place order. This message has in it the sender that is sort of not a user controlled input. It's a sort of automatically tagged, and then the code has to do that access control there. So basically, there is a cursory level of validation, and then for like structure, format, etc. And then you need to basically say, okay, if you're, for instance, canceling an order, does the order owner match up with the person who's sending the message? Okay, why are people switching to non-EVM? So the reason people are, okay, so there are a few reasons. I don't think it's like a particularly profound take here, but basically, if you're treating the chain as a black box, your hands are kind of tied behind your back with regards to a lot of feature development. Like for instance, let's say you're building a PERT protocol and you're building it on a general purpose roll up or chain. You have the problem where most of your Oracle updates are usually going to be based on a contract that is, say, like a chain link or a Pith contract that's on chain that requires a transaction to update it. Which means now you're exposed to this DOS vector where people can somehow spam the Oracle update and get people liquidated or whatever by censoring those transactions. If you were building on your own stack, you could move the Oracle in protocol and basically have it at the beginning of every single block. Update the Oracle price feed, and this allows you to get around these like massive classes of security issues or attack vectors, right, in a pretty elegant way. Another reason is, you have protocols like Uniswap who have paid 2 to 3x their FDV in fees to Ethereum from their users, even though they've been taking nothing, right? And this is a big problem if you're an application that has PMF. DYDX, I think this was one of their big reasons, was like, why are you paying rent to a layer below you when you could basically bootstrap an equivalent or similar amount of security with your own asset? Yeah, so I would categorize it as expanded feature set and sort of sovereignty, both economically and also you can do what you want. Thanks for the, okay. Did you begin to utilize ABCI++ for Osmosis? Yeah, so ABCI++ is basically the thing that lets app layer access consensus layer. We have a bunch of features that we have been developing for ABCI++. We haven't put anything on mainnet yet because it's very fresh. I think the most recent version of the Cosmos SDK has this live, and we're just very carefully interacting with it. The first thing that will be live will be an in-protocol Oracle for Osmosis. This is the same thing for DYDX. But we do have other in-protocol things that don't rely on ABCI++. Like at the top of each block, we have the chain backrun the core DEX. So these kinds of things are, we for instance allow users to pay their transaction fee in any token, and then we swap this on the back end each epoch into Osmo. So these are non-ABCI++ related features that are basically application specific. Yeah, but in like probably a few months, we'll have our first ABCI++ app live. Okay, sounds good. All right, I'll move on then to the common classes of security issues. So the first class is non-determinism, and this is something that, if you're familiar with, say, like auditing Geth or something like that, it's pretty obvious. If you're coming from auditing contracts, it might be quite non-intuitive. Basically, non-determinism, or let's just say determinism, is that for the same input, all of your code gives the same output for every node in the network. And this is somewhat trivial. If you don't have this, then it's not clear what people are agreeing on, like what they're coming to consensus on. And having a problem with non-determinism is a massive issue. In most cases, it would lead to a chain halt or a chain to fork, or in some sort of edge cases for honest validators to be slashed unfairly, and these are all really bad. Most Cosmos chains would probably classify these as like a medium to high severity issue, and it's normally not something you have to worry about when you're developing applications. However, with the Cosmos stack now, there's your changes to your core code base can actually introduce non-determinism. So let's get direct and right into examples. An obvious one is their non-deterministic randomness. Languages like Solidity just don't let you do this. But if you're using Go, you technically can, and you won't see this in like a production code base, but sort of like first-time developers sometimes try to introduce randomness through using like imported Go packages, and this is a pretty clear sign of non-determinism. Iteration over Go maps is actually surprisingly common. Sometimes you'll even sort of see very experienced developers make this mistake, where the way that Go maps work internally is there's a certain non-deterministic hash map, and if you try to iterate over it, two validators running the same code might get a different order at the end, and this would lead to the chain basically app hashing, so basically forking. Time handling is okay. This is also a super low hanging fruit. Basically, if you see a time.now in the core state machine, like in the core logic of a Cosmos code base, it's very likely that there's a big mistake there. And you should be using, there's a built-in block time that is deterministic. I think like this is just one of those things where it's not very well documented that like this can lead to non-determinism. So actually, a lot of newer developers do end up having these kinds of things sneak in. And then obviously, like any form of network request or API call is also like basically should be completely avoided. If you try to do an HTTP request from your core Cosmos SDK code, and if you try to do it, then there's no way that you can tell the difference as a chain between a validator who had an API call that failed and a validator who's acting maliciously. And so this usually is sort of at risk of having honest validators get slashed. And in general, it just like cause a lot of headaches. There are potentially ways to make this work, but they have to be handled with great care. And the specific cases, maybe we can discuss at the end if we have time. There are many other examples of non-determinism. I guess I dropped a few more here. Concurrency and multi-threading is actually fine in some cases. You just have to be very careful about the result being deterministic. And then I guess cross-platform floats. This is actually a pretty big rabbit hole, and this happens. The other big one I think is that you have to be careful about gas totals. if you have determinism everywhere else in your code base, this is usually fine. But sometimes reads from state can be non-deterministic, and if it's sort of one of the earlier examples, and this can lead to two validators getting a different gas amount for the same transaction, and that breaks things as well. Okay, sort of whizzing through this. Maybe I'll slow down for the next ones. The next class, I think this is one that's like very interesting, and also one that I guess if I were to guess someone who's onboarding to the stack, what is the first sort of high severity bug they would find? It'd probably be in this category. It's a very common foot gun, and this is basically having a panic be in protocol. There's a so we were talking about earlier where you have code running in, for instance, at the top of a block or before a block. There are two types of code run in a really like any blockchain code base. The first is code that's run in block, that's like properly metered, etc. And the second is code, all the other stuff, right? Like code that runs outside of blocks, in between blocks. And the good one major benefit of the Cosmos stack is that it allows you to add arbitrary logic in these sort of out of block components of the code base. And the problem with this is if you have a panic that is somehow triggered in these contexts, this halts the chain. And I think that yeah, there are things that like we could do better at the infrastructure layer, basically just catching all of these panics, etc. But you don't want to like catch all panics because there are times when you want to halt the chain, like if there's an obvious like I don't know like internal math error or something. But in general, like this is basically how a lot of New York developers in this ecosystem got is they accidentally introduce a place where a panic can be triggered. Like for instance, in Osmosis, in our sort of begin block code, we run internal arbs in every block or in between every block. This means that our swap logic is used in out of block code, sort of in protocol code. And that means that if you can trigger a panic through Osmosis's swap function, you can halt the chain. And this, of course, means that like if you can escalate any issue into a sort of panicable issue, you end up with issues. You end up with a chain halt. So let's go into some examples that are exploitable. One obvious one is overflows, where if you can get an overflow to be triggered in out of block code, you can get the chain to halt. A very good example of this is spot price, where the spot price function is not called during, say, a swap. So if you can manipulate the spot price using a swap, then you technically have an overflow, but this overflow won't get hit until you call the spot price function. And if you have the spot price function getting called in begin block, then now this panics and halts the chain. So this was a bug that we caught in our internal audit for Osmosis. The solution to it is basically to have this defer that catches the panic. But again, like you don't want to catch all panics. You want to like selectively catch panics in a way that protects edge cases that are expected. If you were auditing Osmosis's code base and you saw the spot price call without this defer, then you would have found sort of a high severity chain halt. Another one that came up in an audit for Osmosis that was maybe like a year and a half ago was this notion of bulk coin sends, where basically we were checking we had a module that allowed people to create custom native tokens, and then some stablecoin providers wanted to have blacklist access. And it turns out that actually, if you have a blacklisted token that's part of a bulk send at the end of a block, then this could trigger a panic. And this didn't get caught because send coins doesn't allow you to validate individual coin transfers. You can only sort of move the entire transfer into a block. So you end up in a scenario where either if you have a single blacklisted coin in that entire batch, then the whole thing gets bricked, and essentially whatever that feature is no longer works. Or if you don't check the whole thing at all, then you have a panic and a chain halt. So this is the correct way to do this is actually to split up the send coins into like a loop through individual send coin transactions or calls, and individually check each coin for specific specific properties. This is a little unwieldy, but it is important because I guess the great power, great responsibility thing where having this much control does introduce some risk. Okay, so we've covered non-determinism, and we've covered in protocol panics. I'd actually say that like those two are particularly common and easy to hit foot guns. The remaining three are, I guess we'll say, like increasingly nuanced, with the exception of I think the last one, which is also actually I think that'll be a good like carrot. I think that has a lot of you'll probably see that in a lot of code bases. So unmetered computation is super interesting, and again something that one normally does not have to think about when writing or reviewing say solidity contracts. The key point here is that gas metering is not necessarily automatic. If you're doing Cosmos contract stuff, you don't have to really worry about this. But there's no gas limit for code that's run out of block. This is like intuitively, this means that if you have node code, it's not like we can't set like a global gas limit for the Cosmos SDK code, right? This is not something that happens. So what we see is the gas meter can keep ticking up as operations happen, but there's no limit. So if you can somehow trigger, say, like an infinite loop in begin block code, you can halt the chain, right? So any kind of unbounded execution can be used to sort of indefinitely halt the chain. And the way you get around this is, I guess there are a bunch of ways you can get to unbounded execution outside of just having a literal infinite loop. Actually, I think this is a one that people should please take note of this. I think it's like surprisingly common, where basically in your Cosmos SDK Go code, you can port out and run execute contracts, like Cosmos contracts. And surprisingly, this is not something that is like automatically metered or limited. If you have a contract call in your begin block code, then that contract call, if they can run arbitrary logic, can like super easily halt the chain by just putting an infinite loop like in their contract. And for a lot of code bases in Cosmos where this kind of automatic integration of Cosmos contracts into the base layer, like Juno, Neutron, etc., like this is a real attack vector, and it's also super easy to miss. So the way you get around it is by creating a child context with its own gas limit. I guess in the article that we wrote, we have like a specific example on how to solve this. But if you see a sort of pseudo contract call in Go code, and it's not specifically metered, like you don't see a gas limit of like 5 million or 10 million or whatever just right above it, then you should check to see if that code can be run in begin block. If it can, it's usually a super easy way to halt the chain. And there's no way to catch this really, like unless you have unless you see the exact attack vector. Again, like definition of a foot gun, right? Another slightly slightly more difficult one to hit is related to math operations. Specifically, power approximation seem to be particularly tricky here, where you can just have very slow conversions, and if this is the case, then you can recall trigger a bunch of math operations with very specific inputs, and cause block times to blow up. And if it's sufficiently slow, then you can technically halt the chain. I guess this kind of ties into I guess I thought I had okay, this is in the last section, but this ties into the one of the later topics, which is basically mispriced gas. And generally speaking, if you can pay 1 unit of gas and get, say, like 100 units of gas worth of compute out of the chain, then this is an effective way to attack and halt the chain. This is an equivalent form of like unmetered computation, right? We can call it poorly metered computation. Okay. Let me check the chat to see if for the non-determinism, do you have any problem with the Golang version? Yeah, the Golang version should be fixed. Like, you don't want to be like just blindly updating Golang, and also, God forbid, have your validators run different versions of Golang. But I don't. I mean, I think this. I'm not sure if like we specifically experience. So Osmosis runs on I think 1.18. There are changes that Go makes, so you have to be very careful about reading change logs, etc. If you're upgrading to a new version of Go. Yeah. Time.now caused non-determinism in Cosmos. Yeah. So for context, almost all of these all of these issues are from like direct problems that came up in either the Cosmos SDK or Osmosis or some other major Cosmos code base. Yeah, these are basically, like I should have mentioned, like a distillation of like 2 years of very serious vulnerabilities that were found and stressfully debugged, and yeah, hopefully never again. I guess this next one, with that said, is one that was particularly painful. So this is basically the way that the Cosmos SDK stores state is this like IVL key value store, where you can prefix iterate over the keys, and I'll have code snippets later. But the TLDR is a lot of the times the things that you would want to key things by, like let's say pool ID or position ID, are partially in control of the user. And this means that they're sort of malleable. Like you can affect what the key is as a user. And when you're doing prefix iteration over these keys, there are a bunch of things that a bunch of scenarios that lead to like very difficult to test, but like trivial fun drain critical bugs that are really easy to fix. But it's just like, again, like these are foot guns, right? It's just I'll give a specific example. That basically, if you have your store prefix ending in a serialized ID, like a pool ID here, you can imagine someone trying to iterate over, say, all pool IDs. Or address and pool IDs. So this was a bug that we caught in Osmosis for concentrated liquidity about a year ago. What happened was we had our validation logic that checked, okay, get all the positions that this account has, this address has, and just check that they own them. And because you could, because the pool ID at the end was not cut off with another separator, you could technically bypass this by like if you were a valid owner of pool ID 10, you also got access to pool ID 100 and 1000, and basically all the pool IDs that were sort of prefixed with 10. Again, like this seems super silly and very simple. Almost like for anyone who's like worked with these kinds of like key value stores, it's like almost like embarrassingly simple. But you would be surprised how commonly this gets messed up, where you have a serialized ID that the user can control be at the end of the key. If you're iterating over these keys, sort of like prefix iterating over these keys, then you can literally get access to like positions and pools you don't own, right? There are two solutions to this. One is to just add another key separator at the end. A little slightly more elegant solution is to do your keys sort of big endian, that's what you'll see in sort of most Cosmos code base, in Osmosis code base. The reason it's slightly more elegant is you just save the storage byte, but like a lot of people just add the key separators at the end just out of like paranoia because it's so easy to exploit these things if you get caught with it. So yeah, okay, so there's that. Key collisions is you won't see this on like unless a person who's developing is like very new. But basically, you want your keys to be unique. In this case, you have pool prefix and then two tokens and a spread factor, or I guess the fee, right? There could be multiple pools that have the exact same key here. So this is a massive issue. If all of your tests assume a one pool per token pair, then this issue would not get caught. But it's obviously trivially exploitable. So key uniqueness is very important as well. And then one that I'm just throwing in here for posterity is that prefix iteration bounds have gotten a lot of like even seasoned Cosmos developers off guard. Just be very careful about when you're prefix iterating. When you're forward iterating, your bound is just the result that you want to go until. When you're going backwards, you want to start with an offset of 1. And this is somewhat unintuitive and honestly a bit of a design flaw of how we did iterators in the Cosmos SDK. Yeah, here it is, I guess. All right, so the last section, I feel like I've been rambling, is fee markets and gas issues. This is also something that you'd not have to worry too much about if you're just developing contracts. When you're working in an environment where the code you're running can be run outside of a block, you need to be very cognizant of these things. The TLDR is like very sort of like an ideological descendant of the unmetered computation class, where if you are able to squeeze out more compute from your chain than you're paying for, then you can trigger a chain halt. And also, if you're experimenting with fee mechanisms, you need to be very, very cognizant of these things. So let's say you're auditing DYDXV4. Their memclob, which is their in-memory order book, allows for feeless orders based on quotas. Now, this is something that needs to be very carefully parameterized. If, for instance, they allow for any account with 100K USDC to do 1,000 orders for free, then you need to be very careful about what the real cost of 1,000 orders is and whether that is a DOS vector. Because if it's too easy to spam, like let's say it was 1,000 orders for free per 1 USDC, then you could just create a bunch of free orders for like a small amount of money. You could halt the chain, right? There are various protocols in the Cosmos ecosystem that are experimenting with fee market design, these issues become very important. So a very like close to home problem for us for Osmosis about like around when Celestia launched, which is we were handling the launch for TIA. We realized that actually our fee market was insufficient to handle the amount of load that we had. We like literally the organic usage of the chain was basically halting it. We ended up in a scenario where, we had like to implement EIP 1559 in like 6 hours. We did get it done, but it was extremely stressful. And this is one of those things where depending on who you ask, like this is either a non-issue or a very big issue, and usually that depends on whether their protocol has actual usage or not. The correct solution to this is to have the fee market be in protocol, and not do this sort of like tacked on mempool style fee market that we did. But that's a long-term solution that will be part of the Cosmos SDK. If you're reviewing a code base and you see a fee market that is not accounting for high usage in the system, then you can be reasonably certain that this can be spammed and like very cheaply. Another example is mispriced state rights, which basically, if you have linear iteration over anything, then creating those objects that you're linearly iterating over must be also charged for in scaling gas. Like, let's say you have a scenario where you are transferring all of the tokens in one account to another account at the end of a block. Then that means creating a token that goes into the account that's being transferred from needs to have this additional charge like we have here. And if that's not the case, then I can just create a million tokens, put them in there, and halt the chain. So again, if the pattern here is that actually a lot of these attack vectors are chain halt vectors. The base logic ones are pretty similar to like any other ecosystem. And then another common foot gun is when you when you charge a manual fee for certain functions, especially Cosmos contract functions. Like, let's say, for instance, you have a contract that creates a pool, and this you specifically charge like a 100 Osmo fee on this pool. If the contract is being called by other contracts, there's no way to bubble up that 100 Osmo fee to the callers of the downstream contract. So what you end up with is a scenario where the OG contract can never be used, because the fixed fee is like tacked on instead of, it's not using the like gas infrastructure of the Cosmos SDK. So the way you get around this is by consuming the fee as gas, and this is pretty easy to add. But if you, so basically it should trip a flag in your head if you ever see someone charging a fee in the form of like, transfer to the module account this much tokens. Okay, and then I guess I'd imagine that most of the people listening to this care mostly about like higher severity issues. One common thing that comes up that's like super annoying to deal with for protocol developers, that's not necessarily like a security bug, is is like some people add transaction logic in the begin block or anti-handler that is not part of the sort of simulation logic, and a lot of wallets use this. So if, for instance, we put in gas intensive logic into like this code block, this is kind of a toy example, but in like a real code base, it'd be a little less obvious than this. Then this would basically break all of our wallet integrations, and they would need to go in and like figure out how to manually simulate the changes. And again, it's not going to get you a big bug bounty, but if you're auditing a code base, and something like this is actually will save the developers a lot of pain. All right, that's all. I think it's been 45 minutes. I hope I didn't lose too many people. I'm happy to take questions now, or we can do a discussion for the last 10, 11 minutes. But yeah, thanks, guys.
Perfect. Yeah, thank you so much, Alpin. Incredibly informative. A ton of information. Thankfully, we do have this recorded, so we'll provide it to everybody publicly afterwards. But if you have questions right now, feel free to unmute or just type something up in the chat, and Alpin would be happy to answer any questions that come up. So we'll give it some time. I think somebody already asked a question during the presentation, and folks will trickle in. So if you want to take a peek at what's there,
Sure.
we can start then.
Sounds good. Yeah. I also was a little intentionally maybe a bit rambly. I wanted to make sure this was a good reference for people later as well. So the question of how's my experience with reporting bugs on Cosmos? Is it mostly analytical line by line or white box fuzzing? Okay, so I think that there is a lot of low hanging fruit for fuzzing that I think actually, if you just went through, like, if you're auditing a code base and you just built your own custom fuzz test suite, you'd probably catch things that that seem like genius auditor, and this is a bit of a shortcoming of our testing infrastructure. I've tried to contribute to this. I built out a mutation testing suite that sort of runs out of the box on any Cosmos code base, or really any code base, but it sort of natively supports Cosmos math, etc. Yeah, I would say like there is low hanging fruit with fuzzing. Some things you just can't catch with automated tests. So I would say that for a lot of the really big bugs, these code bases are generally very well, like the people who write them spend a lot of time reviewing. And if you're going to find a bug in the Cosmos SDK, it's going to be line by line. Do you have a checklist when you're auditing a Cosmos protocol? I think that this post that we made is a decent checklist. Actually, this presentation is a much more in-depth version of it. Yeah, I would say things like, well, first of all, if the code base can go live, like if you can spin up the nodes and run it on testnet, then chances are a lot of the boilerplate is fine. Well, you want to for logic issues, yeah, you want to check, for instance, like the key malleability stuff, like go through all the keys and see, like, are they properly either switched to big endian or appended with key separators. But these types of things are like, in like 10 minutes of searching, you can find any obvious bugs. And then the rest just requires deeply understanding the code base. And some of these are complex. So I wouldn't say there's a checklist yet. Is there a security best practice? Yeah, I mean, we do have a security section for Osmosis in our contributing .md. But I will say, let me send this post that we wrote. I think this is probably a good reference. Basically, it's a part 1 of a security handbook. And this should actually have a lot of the stuff that I talked about, and also, serve as, I guess, a checklist or starting point for people. How do we create a POC if you find an issue? Yeah, so there isn't, unfortunately, there isn't a Foundry or hard hat equivalent. The good thing is that, for instance, one of the first things that we covered was the whole, like, where do you start when you're auditing a code base? If you, for instance, submit to Osmosis a unit test that finds a bug at the message layer, i.e., there's like a message server function that you are able to break with a Go test. This is usually a sufficient POC. You could technically run a local testnet. Osmosis makes this quite easy. There's a local Osmosis, which you can run on any computer, and it's pretty easy to set up with a few CLI commands. But most Cosmos code bases won't have this, and we don't have like very good generalized tooling yet. I'm sure that this will come around over the next year or so. But in the meantime, if you're like, your POC is usually, it's sufficient if it's literally just a unit test on a message. This might seem a little simple, but like it really, like, that is really the magic part of the code base to find bugs in core logic. Like if you can figure out a way to trigger panic there, and you know that code runs in begin block, that's enough. Like you don't need to actually create a chain and then halt it. You could technically do that. It's just too much work, and most protocols will accept the bug without that. Part 2, it's just, these things just take a lot of time, honestly, and I really want to do one on Cosmosm because I'm pretty confident that like Cosmosm will be something that, for instance, like CTFs are probably gonna have a lot of Cosmosm challenges before they have Cosmos SDK challenges because it fits nicely into contracts. But I think this is yeah. I guess when we get around to it, um, the Cosmos SDK issues are really the big part here because that's where most of the capital flow is. So it's a coin flip whether we do Cosmosm next or IBC next. Yeah, I'll post in Spearbit channels when we do. All right, I see. Okay, can you please explain the pool ID bug again? Okay, good. So for the pool ID bug, actually, we have a very specific. So in the appendix of the post that I sent. Oh, wait, let me double check. Yeah. Okay. I figured this was something that people would find interesting. So in the appendix of the post that I linked, there's a step-by-step, very thorough breakdown of exactly how you would exploit that bug. I did kind of gloss over it, the specifics, but yeah, it's under key malleability and prefix iteration attack example. Okay, I see someone is typing, but I guess we are coming on time. I'm happy to stick around until the end of the hour if people have other questions.
Yeah, I think there might be a few more folks. I see typing as well, but yeah, we'll give it until the hour, like you said, and then we'll just wrap up. But if anybody has any questions until then, feel free to drop it. And if nobody has anything at all within the next minute or so, then we'll go ahead and close off. But we'll give it a bit of time.
Yeah. Okay. Yeah. Also, if anyone is like interested in like learning more specifics or once my DMs are open and I'm happy to like help along. Like one of my personal goals is to onboard more security minded folks onto our stack. Of course, like in the short term, even like I think that this shouldn't be that big of a. I think there will be a lot of very like profitable audits, etc., that like will pull a lot of people in. My hope is that it's like a good enough carrot, but I don't know. It's the different motivations for everyone. But yeah, my DMs are open, especially anyone who's sort of part of the Spearbit community. I'm happy to like walk people through onboarding, etc. There's a lot of knowledge that's hard to replicate and not documented. That should be a good edge. Okay, about Cosmos SDK security, is there any more resources on this? Yeah, I mean the Cosmos SDK docs are actually quite good. Now the security section of the docs are like the stuff I just talked about because there wasn't one, and we just made the post that I linked the official security docs of Cosmos SDK. So like this is like very cutting edge. like there's basically um, the next post that we write. If you read it, you'll be reading it before there's any official documentation on that stuff. Again, like these types of standards don't get developed like by people just like sitting in a room and thinking about it, right? These things happen as bugs get encountered, as like developers go through like very painful war rooms, trying to like fix issues that could have been quite easily avoided. And then eventually, like after all of that scar tissue gets built up, we like write these nice little blog posts that hopefully prevent future people from making the same mistakes. In this case, I assure you, this will not prevent future people from making these mistakes because they're too easy to make. So actually, yeah, I think this presentation plus the article I linked are probably the best resources to date on Cosmos SDK security, at least anything that's publicly written.
Excellent. I think we're coming up on time. But to echo kind of what Alpin said, Documentation for the Cosmos ecosystem is fairly robust, and we're seeing a bunch of interest in terms of protocols building in the ecosystem. It really is a good opportunity if you would like to have a focus that's non-EVM in terms of security review. And highly recommend, again, like Alpin said, reach out if you're interested. And yeah, we do have as another carrot. There will most likely be some fairly large security competitions in the future if there's not enough incentive yet via Cantina. So yeah, get churning away on the content. Think this seminar is a fantastic start. We will post this, and we'll do our best also to, if we have time, to make a write up on it, so we can have something a bit more cohesive. And Alpin, if you want to share that through Osmosis, you're more than welcome to. But yeah, excellent presentation. We'll hand it off to you, Alpin, if you have any closing remarks.
Awesome. Yeah. Thanks for joining, guys, and for sticking around until the end. Yeah. Only thing I'll say is my DMs are open if anyone wants to, needs help onboarding into the stack. And yeah, I think it's a really good time and very good opportunity to get involved and properly onboarded. I think, especially with sort of audit competitions coming up, but also just in general, like, we've definitely increased our audit spend a lot. Our Osmosis, I know a lot of other protocols have as well. And there's a real opportunity on the table here for sort of the first generation of security legends to be born in this ecosystem, and it's all on the table right now. So yep. And with that, I think we're at time. Yeah, thanks for joining, guys.
Perfect. Thank you so much, Alpin. Take care. Thanks, everybody.